So I will switch to some different sphere. Okay, I want to talk about risk management. I don't think we'll be talking about testability. It's something I've talked about before, but if we have a few extra minutes, I might. Okay. Risk. So let's keep it interactive. What are some major risks for software projects? What are some major ways software projects go bad? You can include risks that might apply to clients, but also to like commercial or institutional projects. Scope creep. Yes. Scope creep is a big one. So there's an initial well-defined smaller set of features, and somehow it starts to pile on itself, and you're promising more and more. So Rob.
Yeah, I was going to say scope creep, but the other one I was thinking is really understanding what the requirements are from the stakeholder, and not, saying this is what it is and running with it and getting too far from kind of like golf of evaluation or something like that. So yeah, just stay close to what stakeholders do.
Yeah, that's good, and that is a side of scope creep. And it's one to which we as software engineers, and I speak sympathetically, are very prone, right? Because we think like, I remember one team project, I won't say the year, but it was within probably just prior to you joining our program, maybe it was the first year of the program doing. We had a team that was building a system for someone in nutrition. And it was a plate waste system that sort of it's a while. But teams get involved in all sorts of neat stuff. So imagine a childcare center, okay, where nutritional scientists want to study like what are kids actually eating. And you might think, well, it's easy, you just record what they put on their plate. Well, no, because a lot of what ends up on their plate they throw away. And sometimes they'll get seconds and stuff like that. So they were building this app for recording like what a child has on their plate when they load it up, and then how much by weighing the plate on a Bluetooth scale, and then how much does it weigh when they're done, and taking photos and keeping track of this by child. Okay? So you have to record like which child is which, and there was discussion about barcodes on the back of their neck, or on their, having RFIDs in their shoes or something, because it was discovered kids were taking off the barcodes and putting it onto other kids, and it's, all sorts of things like this. So anyway, this team had a set of incremental deliverables to deliver this, but then they start to think, right, and this is where it gets dangerous. They started. It's going to be useful not only for childcare, but like we could use this for like schools, and we could use it for like the Canadian military could know what people are eating in the Canadian military. The slop that gets thrown away in the garbage pail. And so they started to elaborate the system and think about all the different ways it can be more flexible for the military. And well, you may not anticipate from what I'm saying what happened, right? It became such a grand vision that they didn't even deliver on the basics, and it ended up, delivering almost no value because it was, just kept on piling on and feature set, right? It was scope creep, but in a way that was elaborating in their own minds its potential prematurely. And there's a principle in software development. Do you know what Yasmin? Yeah, ain't gonna need it. Yeah. And it's a good principle to keep yourself grounded. Like, don't speculate, guard yourself against speculation. And this is a bit tricky as software engineers because it's good to think ahead about how the app will be changing so we can have interfaces that anticipate it and buffer us from that change, so that when things change, we can swap things out and replace it with a new thing without changing the rest of the code. That's a good thing. Flexibility, achieving flexibility. achieving the ability to change things in one area of the system without changing the others. But it is possible you could over-engineer something and put in place too much in a way that just becomes way too cumbersome. And that's one of the problems we have, not only on the scope side, but the design side. So we have to balance somehow between the scylla of having too little flexibility and the charybdis of over-engineering it and having too much flexibility. For those who don't recognize it, that's a reference from Greek mythology. So those are some risks. What are some other risks in software? Yeah, Colin.
Maybe starting with a architecture that's not adequate for when you're developing projects further to kind of contain the features that come later. Like when you started with an architecture that isn't flexible enough.
Yes, so that is a risk. And one of the issues that comes with architectures that are not flexible enough is that architectures are by definition cross-cutting things. They affect the whole system, right? And when you try to post hoc, like after the fact, adjust that architecture, it often destabilizes the whole system. It's like you have to make changes all throughout the system. And that imposes its own drag, right? So it's tough because you don't want to over-engineer this architecture and be speculative about it, because that takes too much work, but you don't want to under-engineer it, and you're going to be spending all the time chasing things all around the system every time a new feature is added in. And you got to get that right balance. And that's why in this class, we speak about making use of like tried and true divisions, things that have been in countless, and I'm serious, like it's got to be tens of thousands, maybe hundreds of thousands of projects. You know, you have this division between like a UI layer, which deals with UI thingies. Now, sometimes we divide that into sort of a controller, which is like user input and like mouse clicks and keyboard or whatever. And then another area is like controller, and then a view, which is kind of rendering a view. But then there's some underlying model or business logic, which is kind of dealing with the heart of the logic of the domain, like the relationship between a vaccine schedule and for a given kid who has vaccine history, what's needed, like what vaccines they need, right? And as they age, what new vaccines might get. That's kind of like business logic. For the team involving Oculus, it might be things involving, you know, the layout of the space, and also things like transforming a time series into its embedded version. So a time series of data points one after the other into a series of vectors, one for each time point. And that transformation, being able to relate that, like a given vector, what does it relate to over in the original time series? A given vector kind of has a home in the time series from whence it came, from which it came, from, to not use Middle Ages English. So in the business logic, we have kind of the core logic of the system. I think for the DICOM project, there's some relationship between DICOM files and tags that are in them, and some ways in which, like, you can find the tags in a DICOM file. That's not UI stuff. That's like stuff having to do with this area, like how DICOM files work and what their logical divisions are and where you can find things. Okay, so there's a business logic which is dealing with like the underlying rules of the game of engagement for this area. And then there's often a persistence layer. Not always, but this is like storing it in a database or storing it on files on disk and loading it in and saving it out. And maybe it has to do with local and remote files or what have you. But it's a layer for kind of persistent storage. Maybe it's of settings, maybe it's of data itself, what have you.
And these are common divisions that are not speculative, per Colin's point. These are like pretty darn certain most apps have these divisions. And if you break them into these divisions, you have at least a basic separation of concerns here between areas, so it's not all in one hairball. So you're unlikely, by capturing this, you're unlikely to be over-engineering it. There'll be a lot of change in business logic, perhaps, as your knowledge develops, but even more change in UI, and at least those will be isolated from one another, right? Or at least largely isolated. And there'll be change in persistence layer as you go from file storage to a database storage or whatever. You go from a local database to being able to store it on Firebase or what have you. Architectures are one of these things where under-engineering it leads to massive amounts of extra work. Over-engineering it leads to a lot of extra work that doesn't deliver value, and you want to find that good balance. So what's another risk that can occur on projects? So I'd like to call him Jason, but there's a hand up over here and Alex. Yes. Oh, sorry.
I actually just wanted to ask a question real quick.
Oh, clarifying? Yeah, okay.
Would
Sure.
you even like us to, silly, but organize our code into like 3 folders called, like code system, business logic, and UI? Like, would that be better for organizing? Yeah, yes. Okay, so basically put them into those 3 folders.
Can't even do that.
The answer is yes. 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 For most repos, they're going to be in separate areas. Yes. Yes. And there may be additional components that are cross-cutting. For example, logging, multi-level logging. Right? You can distinguish between info messages, debug messages, warning messages, and what's the highest priority type of message or logging action? It records a what? Error. Thank you. So logging might be used in any of these layers, although a system that's multi-tier, and I've got to get to Alex, and then I'll be with Connor with an E.
Yeah.
Yeah.
Question about that as well.
Oh, you have a question about this. But in a system which is multi-tier in the sense of having like some of these, like maybe in some systems, the persistence layer is over on the back end, or more commonly, the UI is in the client, and then these 2 areas are on the server side logic. That's not always the case, but sometimes, which allows, different UIs like a mobile device of one sort or a web UI to make use of the business logic and persistent. Each of them will have a version of sort of the UI layer, but they'll be working here against a common business logic and persistence. When it's on different machines or different logical sort of elements of the platform reached via endpoints, a REST API or whatever, then you will often have different logging mechanisms in the front end from the back end, because it runs in different places and it's got access to different resources, but they might all post to the same HTTPS logging scarfer that ingests messages upon a crash or whatever, for crash analytics. Okay, you want a clarification thing, and then we're going to Alex.
I think you mostly answered it. I was just saying, like, so depending.
Yeah.
So if you had like an actual React, you had a React system, then you had like a from backend server, then those would be separate. And if you actually just had just a React app, then it would also be within the React app, and it's sectioned out.
That's right.
Okay.
That's right. And sometimes, you compile other things, like you have Rust code and it compiles via WebAssembly to also run in the client. And it'll be running in the UI. It's not just necessarily JavaScript or TypeScript code, right? It could be code compiled to WebAssembly from other languages that run in the client, and those would often have one logger, and then the backend is going to have a different logger. But you want to relate, ideally, you'd like to have some sense of the log messages here, which go with this one, like you're undertaking an action here and it leads to an action here. And so you want to do some thinking about how those, to make them not solitudes to each other. They're not like totally separate. Like this, what goes on here is often in response to a UI action, right? And you'd like to ideally piece them together if it leads to a crash here, like what was going on in the UI that led to that. And that takes a little bit of thinking, you know, how to knit them together, but it could be with things like session IDs that are passed over or something. Does that help?
Yeah.
Okay, yes, Alex.
All right, so the problem that I have would say is one for projects. I don't know if it.
With what project?
If you want something done right, you do it yourself is what people usually say. But the problem with that is you've got a group. So what that problem really shows is that communicating your requirements effectively to someone else is much harder than doing it yourself. And I think that leads to the problem of communication. Is that if you, that's a barrier, and if you can't get over it, then there's going to be unequal workload.
Well spoken, young man. Well spoken. I couldn't have put it better. This is one of the sort of key central problems we're trying to address in this class. How to transform a team-based set of effort into something that can deliver more than just a few of the members of the team working independently or what have you. And there is a point in which teams can be far more productive than any one person in that team, or that even 2 or 3 people in the team. But it takes a lot of effort to make that happen. And it's not chance. It's not just happenstance. It is based on coordination, based on effective communication. But those are kind of very airy-fairy descriptions right there. It's more than that. It's like particular practices that promote good communication, like frequent check-ins and meetings and lightweight documentation and spreading of knowledge, so that what you say about back-end issues isn't gibberish to someone who's working on front-end issues. So you can communicate across these lines, so that you as a developer can communicate to a tester and vice versa, without it being just totally different worlds. So communication is, it's easy to describe it as one term, but the point is it's made up of like specific mechanisms of communication that make it succeed. It's not just chance. We have to adhere to best practices, and an important subset of those that are required for this course, like the meetings at the beginning of each class, are designed to foster that communication, right? Like the use of issues tracking rather than just putting it into Discord, right? Or putting into Slack or whatever your platform. Having pull requests that are communicate what's been done, right? And make it clear. And having reviews of pull requests that give meaningful critique so that the person can act on it. And this is one of the hardest things. Look, I know a number of people in this class are probably real virtuosos at fill in X, right? At coding or at debugging or whatever. But a team that works well, a team that is gelled, a team that communicates well, that coordinates well, putting in place the processes to make that happen allows that team to be far more productive than any one person. It's like that old story of, does your generation know about the story of John Henry? Like, is that, you don't know John Henry? Oh, okay. So John Henry was a famously powerful, super strong guy who was involved in helping to drive through railway tunnels by working against rock surfaces. So he would take a giant sledgehammer and go at it, and he could knock out prodigious amounts of rock at a time. And he was famous for being able to do this, sort of in almost a folklore way, like Paul Bunyan or something like that, the Blue Ox, right? Some of you know what I'm talking about. So John Henry was an amazingly talented guy, but amazingly strong and powerful guy. But ultimately, he was outrun by a new generation of automation and steam-based tunneling equipment and so on, and the right use of explosives that, carefully placed and so on. So John Henry was prodigious, but he was ultimately outcompeted by coordinated efforts involving explosives and steam-based drilling methods, et cetera, that we know today. We can't count on John Henry's. Maybe it's from an earlier generation than you, but does your generation know about a singer called Tina Turner? Yeah, so she had a song, "We Don't Need Another Hero." In software, we don't need another hero. We can't have our processes dependent, we can't have success of our projects dependent on a hero. Because heroes are ultimately, like John Henry, not sustainable. Like we can't keep it going, we can't count on it. And heroes burn out. Take it from the moment. It's much more reliable to be able to count on a coordinated, effectively communicating, high morale team that can work together effectively. It's much more robust. If one person gets sick, the others have shadowed that person, right? Shadowing is another way of communicating. You have to think, what are the particular pathways of communication? Don't think of communication as some undifferentiated good thing. Think of it like, how do we accomplish good communication? And I've given you a bunch of recommendations. Nay, I've given you a bunch of requirements, right, for this course. And shadowing is another good one of them. And I'm delighted to see the teams using shadowing, like yesterday's team. Awesome job. But we have to be thinking about like what particular mechanisms can we use. And don't stop with my recommendations or indeed requirements. Like come up with ideas for yourself. What would help your team? Given your situations, given your barriers to meeting or, people's habits in terms of being able to be contributing to effective, asynchronous feedbacks. Maybe it works for your team, maybe it doesn't. In terms of the relationship of the project manager with the rest of the teams, does it have that element of morale and trust and sense of being represented by the project management, or are there trust issues? Are there conflict issues in your team that you have to work on? These are the human theater side. In the end of the day, the virtuoso coders and debuggers and so on, people who can debug with amazing skill, are incredible assets. Don't get me wrong. But they're incredible assets not just for what they do, but what they can help others do. They can help others do better and reach a higher level of virtuosity. It's not, and look, it's not, and this is a system science concept that we talk about in 394. It's not just about the team as its sum of the parts. It's the team as more than the sum of the parts for a good team. That sounds like just a vapid slogan, but it's not. I mean, good gelled teams. Like I was on the Excel team, right? That wrote Excel in some of its earliest versions. And that was a gelled team. That was a serious gelled team. And it's not the only one. There's actually many other teams in software that are famous for being like unbelievably skilled and productive and capable of what they achieve. Another one is like the Macintosh team, the folks who put together the first Macintosh. I've had the privilege of meeting some of them. And they did awesome jobs because they worked together well. It wasn't just each one was an uber coder and went off and did their own thing. Woz did his thing
Steve Jobs did his business thing or whatever. No, they work together like really tightly, and being part of the gel team is incredibly awesome, and it's not a chance thing. It is something you make possible. It is something that is enabled by the right set of processes, and then it's something that is deep sixed, that is left dead in the water by other stifling processes. And I've, over in my lap, many of you are interested, you're welcome to it, to borrow. I have a book. 50 surefire ways, so particular pathways, particular ways to kill a software project. And it lists like all the ways the software project can be killed. And it sounds like a joke, believe me, it ain't a joke. And it's something which decisions in the software project, not chance. Our fate is not in our stars, but in ourselves. To quote. Julius Caesar, I think. That's Julius Caesar. In the play, not the person. You know, our fate, dear Brutus, is not in the stars, but in ourselves. Or to put it another way, as Pogo said, the enemy, we have met the enemy, and the enemy is us for teams that have problems. I don't like need to put all the blame on the technical folks. Often it's a bad manager that makes bad decisions that can end a team in bad shape. Like someone who penalizes the team for bug reports, saying your quality is bad. You have to up your quality. I'm gonna punish the people whose code has given rise to bugs. That is a kiss of death. That is the kiss of death. That's why I welcome bug reports. It's better you know about something than you don't know about something, right? Or punishes a team whose productivity is low. Makes them work extra hours when maybe the reason their productivity is low is because they're burnt out. Or maybe their morale is low and they need to be invested in, not to have the project manager come down hard on them. There's lots of ways to kill a team. And there's lots of ways to help the team succeed. So this class is about mechanisms, Alex, to help a team achieve that level of, I need something profound, coordination and indeed communication that allows teams to succeed. Okay. Sometimes I read. Okay. More discussion. This is exactly what I'd like to see in this class. So any more things you're struggling with that you want to talk about? What else kills? What else is a risk for a project? You know, make it a little bit sharper. What's else is a risk for a project? Anyone? What's someone from this side? What's someone from other than Ronan from these first two rows? No, just say, come on, what are some other risks that can hurt a team? Specific types of things that can go wrong. Yeah.
You mentioned it a bunch. Well, I mean, obviously you talked a lot about testing, and as the build master, I'm kind of like always. I mean, the worst thing for me that I can think would be something gets into the code base that maybe passed some tests, but the testing wasn't really good enough. And you keep adding, and I mean, the CI is daily, and every single time something gets in, and you don't find it until much later, and it just it seems like everything's passing the test, and so there's that element that has stuck in there, and it can be cascading issues later.
That's right. There are some famous projects which have been killed by those sort of issues. Broadly, they're called test estates, meaning they're things that make their way through the test suite that should have been caught but weren't. But even more deeply, they should have been prevented from getting in there in the first place. So something allowed it to happen in the first place, and then something allowed it to escape detection. And those are a deadly combination, right? And this is one of the reasons, like
for developers, I know putting in place mechanisms for testability. Test hooks, ability for you to sort of artificially create an error-like condition, so you see how the system responds, putting in place logging interfaces or putting in place assertions to help find issues close to their source. Documentation, comments. I know that doesn't, for many people, it doesn't fire their blood, fire their sorry, my analogies, it doesn't fire their spirits up. It doesn't make their heart race. It doesn't, you know, I think Thomas Paine did say fire one. Yeah, anyway, so test escapes are things that are much more likely to occur if we don't have good testability. So investing in testability of your system is in the developer's interest, right? So that they don't get told 2 hours before the deliverable is in, or 2 hours before the stakeholder has to be delivered the system or it goes live. Oh, there's actually a bug we found in your code. Go fix it now. And it's 11 a.m. and you have, or 11 p.m. and you have, you know, a 3:32 deliverable tomorrow or something. So test escapes, you want to also put in place not just investments in testability, but think about different levels of testing and make sure that it's founded on good unit tests and good integration tests. And I'll be speaking more about this next week. Yes, Rob. Speak on.
Yeah, well, just one thing I'm thinking of as an example would be like the Pathfinder Pro, where they screwed up like customary and metric. And
Yeah.
it would have seemed to get through all of the tests, right? But if you have different people speaking metric and customary.
That's right. Yeah, absolutely. And you know, it's interesting you mentioned that case. We'll be talking about some data from NASA projects, which are really interesting and eye-opening in this class in the next few weeks. There are some of these projects that have been observed very closely over years, and where they assiduously, really carefully kept track of the defects found and tested it. And where defects somehow make it through a bunch of the testing, but are only found later. And you'll see it has some really interesting learnings associated with it. But that's an example of a type of error that it's not just a bolt out of the blue. It could have been found by the right combination of testing or static analysis tools, like dimensional analysis tools that actually track the dimensions of things. Say, hey, you know, you're doing the equivalent of adding a person to dollars here. Like you have whatever it is, you know, Newton feet per whatever, and you're combining it with the metric units in ways that don't make sense, right? The units are incompatible. It could have been found, but it wasn't. And it is, here's one of the things with testing. When you find a problem in testing, you should be asking not only how could we prevent in the future, but how could we find this faster? And what other problems might there be out there in the code base that are like this? And so again, you take what might ostensibly be viewed as a failure by a shallow-minded manager. Oh, this is defects in your system. And you turn it into a success by like, oh, we found these other 10 defects in the system that are of the same type. Because, you know, these are other cases which do have the similar logic and where the same problem could occur. And that allows you to leap forward. You don't just want to like say, oh, time to fix it, and you put in a hot fix and you're done or something like that. No. You want to ask, like, where else could a bug like this live? Where else could they be hiding? That will get you a lot further and will help really cut down the number of test escapes. And we'll see that NASA, young man, does exactly that. And I think the Pathfinder mission is a case in point about, you know, a type of defect that they weren't finding through their processes earlier. And I don't know for a fact, but I know there's been a great rise in the amount of analyses done for dimensional consistency since then. And I suspect it's one of the reasons that they invest in high high quality sort of static analysis of their code base. Okay, so risks are key needs. I want to communicate just key needs to address. We talk about risk meaning uncertainty about a consequence, and risks are uncertainties that have consequences. Okay. So we talked about a bunch of these. I put a list up here, and there's really a good literature listing out, common risks within software. So risk management is about identifying, analyzing, and making decisions with regard to risk as an ongoing process. It's not a one-time thing. It's not just done at the beginning of a project. It is done on an ongoing basis, as part of the brainstorming. And people should be thinking proactively about these risks, just like they should be thinking when they find a defect, like what other defects are there, like that, right? And it's sometimes said that today's risk is tomorrow's problem. So you want to, if you don't aggressively attack risks, they will aggressively attack you. That's Tom DeMarco, I think, who said that. And good risk management. This is a key point. Good risk management is what allows you, good risk management is what allows companies to do high risk projects. It's what allows companies to do projects at awesome scale because they have the ability to manage the risk. If they can't manage the risk, it'll collapse. A project at that scale. It's really what allows them to succeed at awe-inspiring projects. It gives you much greater chance of delivering successfully. Okay. I want to highlight, though, just a few key things that I want to see from you. So there should be risk identification, and all the teams have done a good job of thinking about some risk. But you want to also do exposure analysis, basically asking, how bad is this risk? And it's a combination of two things. Number one, severity. Number two, probability over time. And then you want to be asking, how do we handle it? And the two things that I want you to think about particularly strongly is not just mitigation, but contingency planning. Okay. The good thing is, here, I mentioned Tom DeMarco's quote, today's risk is tomorrow's problem. But good thing is today's problem is tomorrow's risk. So we can learn from our problem and we can learn to manage them as future risks. If we have a problem, if we find a defect, we can ask, how can we prevent defects like that from coming about in the future? We have a proof of concept case that can be turned into that it's a problem, and we can start spotting out from the risks. Okay, I want to talk though about risk identification. You should be undertaking at these regular meetings, including retrospectives, and you should be recording this for your sake and for my sake. Okay, and I'm not gonna police that side of things. There's ways to do it in terms of brainstorming that help identification. But what I need to see is something I didn't see in any of the projects, and I want to see it, which is assessing risk exposure. So for each risk, you should say, and look, this could be on a scale of low, medium, high, or it could be on 0 to 10. Any of those is fine. What's the probability of relative probability of occurring? High, is it low? And what's the loss if it occurs? How bad would it be if it occurs? And you multiply the two. You get the expected value of the loss for those who are comfortable with probability. Probability and loss are both subjective. I mean, look, there's no magic here, right? We're trying to judge from our team's experience, and you want to tap other people in the team. How probable is it? Don't just do it on a one-person basis that the risk manager can solve. Because you might not be nearly as good a position to say how janky is this area of the system than the developers and testers, and particularly the testers. So you need to consult with people to get a sense of the probability it will occur, and sometimes even for the sort of how bad it would be if it occurs. And you take the multiplication of those as as an idea for, its expected value. How bad is it overall? And I want you to report those things. And I want you to distinguish things that are contingency plans. The idea of a contingency plan is something that you have in place just in case something goes wrong. Everyone is clear. If something happens, if a risk materializes, you will do X. You've agreed to it up front. You haven't done anything else to prevent it. You just agreed what you will do if it comes about. That's a contingency plan. I knew a guy at MIT who was been in charge of a $6 billion launch of an oil rig in Norway. And he did effective contingency planning. When it was launched, they had a set of helicopters to fly out just in case a problem developed. And lo and behold, that's what happened. The helicopters dropped scuba divers in, they welded shut a leak that had developed, and it saved the oil rig from sinking. $6 billion of investment saved because he paid a couple $100,000 just, to have this to the helicopters that responded in that case. So contingency plan, you're not doing something upfront other than putting in place a plan, what we will do. We're getting coordination, agreement on it if this comes about. You're not making a big investment up front. Mitigation, you're actually taking action now. You're putting in place resources now to prevent it from happening, or, this is important, if it happens, lessening its severity. So mitigation we use for both those things. You try to prevent it from happening, or if it does happen, you try to make it less severe. It can be either of those, okay? And I want you, for your risks, to distinguish between ways you're handling them with contingency planning versus mitigation. Any given risk, it could be either of those or both, and that's fine. But all of the risks management strategies that I'm seeing right now from two teams which listed them are mitigation, and that's great. But you should be thinking about contingency planning. Contingency planning is often lighter weight. You don't have to do something now, but you're all coordinated. If this happens, you will meet and you will do this, or you will enact something that doesn't even require me. Okay? So I want to see risk exposure, probability times loss, estimated for both, and I want to see mitigation. Okay? That's all for today. I have one apology to make. Normally I hold office hours in class here. I need to be at something that goes from 2:30 to 3, and then I'm going to be at my office after. So if you want to meet with me, awesome, but you'll need to come to my office, okay? But I'll be there just after 3 from this other thing. It's just, I can't push it later because it ends at 3 o'clock. Thank you, everyone, and let's keep the interaction up.